Hello, I am Pramit Kumar Senapati, Chief Subject Matter Expert for Earthquake Analysis Advanced Video Training Series. So, in this particular video training series, you can learn how to apply response spectrum seismic analysis and in compliance with the IS code and IBC and EBC code, how you can check your structure for failures and how you can predict and redesign the structure as per the course that we are going to learn. So let me brief about the learning objectives first. Our learning objectives are IS 1893 2002 provisions and different code compliance and its different features, and also I'll give you overview about the Staad engine, how it operates for response spectrum seismic analysis, and next we'll move to a G+13 structure and we'll apply the different concept for configuring, for assigning the response spectrum seismic design, and we'll apply over the structure and how to configure different seismic parameters, floor width for response spectrum seismic, live and dead load assigning and its configuration, and what exactly will be the factor that we'll discuss, seismic code and seismic live load assigning, and different rules for defining the load cases that will look how Staad calculate the lateral seismic load that will understand, and Z by 2 into I by R calculations for your AS applying over the structure, and how Staad calculates SA by G factor, base shear and seismic lump weight relation and configuration that I'll be discussing, response spectrum different configuration over the project, spectrum direction load configuration, rules for applying spectrum load in Staad. Then we'll move to the analysis sprint, analysis post sprint for getting the results, and we'll look in the post sprint how to configure story drift and lateral seismic load and seismic code compliance different rules, and response spectrum analysis as per the IS 1893, and how to check code in compliance with the IS 1893 that I will brief, and reassigning the design parameter based on the data, and doing the critical analysis data and reading for getting it validated, and finally we'll apply over a project which is G+33. So let us start understanding the basic code compliance. So for that I'll be taking this as my reference. So this will be the IS 1893 part 1 2002 codebook, and here you have the guidelines based on that you can see here. So general provision of the building, part 2 liquid retaining tanks, bridges and retaining walls, industrial structure, dams and other structures. So the part 1 typically is for the residential and other structure which largely we use for commercial projects. So in line with other UBC code, the compliance has been designed so that once you know about the IS 1893, easily you can move and migrate to IBC and UBC codes and other different country code. So this is the seismic zone of India, and you can see based on the different areas designated as zone 2, zone 2, zone 4 and zone 5. These are the zone 5 regions. And next you can see here the different reference of the code like 456, 2000, 800, 875, and for the dead loads part 1 1987, imposed other live load 1987, wind load, and so on. And different terminology you can find during your earthquake analysis like EPGA, effective peak ground acceleration. So you can see it is 0.4 times the 5% damped average spectral acceleration between 0.1 to 0.3 second. This will be taken as 0 period acceleration ZPA, and flow response spectrum. So you can go through this code book very precisely and carefully. Importance factor, which I will be using during my code. Intensity of earthquake, and this is very important, which we are going to use as the horizontal acceleration coefficient AH, and design lateral force, the modal mass and modal participation factor. This all I will be using inside my training series. The seismic weight, the spectral response factor SA by G, this particular factor denoting the acceleration response spectrum of the structure subjected to earthquake, ground vibration, and depends on natural period of vibration and damping of the structure. And QIK also we are going to use mode shape coefficient and natural period T, and TK also we are going to use mode natural period. Zone factor, different zones having factor like zone 4, 5, 2, you will be having the factor, and response reduction factor R, and base dimension, and design seismic base shear. This all we are going to use inside our training series. And here you can see the story drift. It is the displacement of one level relative to other level. When you are going to compute the story drift, the between the floor, how much deviation you are getting, that we are going to calculate, this included, and whatever the weak story, that you can predict. And these are the nomenclature and symbol which are being used inside different formulas. And here you can see the general principle and design for earthquake as per the IS. The ground motion is the first factor, the change in occupancy and the assumptions, and what all load factor you can consider in the auto load combinations. Soil structure, type of soils which you are going to use, and different zone and its design spectrum. This also we are going to use the AH, Z by 2, I by R, SA by G. This formulation also we are going to configure inside Staad. And Z you can see zone factor, and inside the table it is given earthquake code already configured inside Staad, so no need to remember the table, automatically it will help. Importance factor also already configured inside Staad, and R response factor you have to see from the table that I will show you. SA by G automatically Staad calculates, so no need to worry about this. So this also already there. And here you can see for different structure the percentage of permissible increase in allowable bearing pressure or resistance of soils. And for different zone you can see the depth below ground is mentioned here, and the net value which is coming, that also is mentioned, and remark is given for values of depths between 5 meter to 10 meter. Linear interpolation is recommended during the analysis. And this is the zone factor. These all are configured inside the Staad engine. And here you can see for the rocky soil or the hard soil what will be the SA by G in this particular table for the medium soil. And here you can get all the details. The seismic weight, this is the damping percentage, how much you can give, and the factor. And also you can find a couple of other important parameters which you can use this. The response spectrum reduction factor R, which we are going to use, will be using this 5 as the still moment resisting frame as per the SP6. So this we are going to use in our project 5. And for different project you can see these factors, this we are going to refer, these are. And this is very important, and when you go for the percentage of imposed load to be considered in seismic weight calculation, that is the live load, what percentage you are going to take, percentage of imposed load. If it is up to 3, then 25% you can take, and if it is above 3 you are going to take 50. In our project, as it is 4 kilonewton per meter square, we are going to take 50%, that means 2 kilonewton per meter square seismic contribution, or you can say imposed load because of that. So let me show you about the seismic weight calculation. That is the live load. the response spectrum analysis as per Indian IS 1893 Part 1 2002 code in compliance with that. So this is basically the fundamental principle which you can see in this particular slide as the Staad engine how operates for response spectrum seismic dynamic analysis. So the design lateral shear force at each floor in each mode is computed by Staad by using IS 1893 by using these below formulas. So this formula having two different sides, left side is QIK and right side is AK multiplied by phi IK multiplied by PK multiplied by WI. So user need to input this two factor AK and WI. So what is AK, what is WI, what is PK? So all these details you can see the refer the code number 10, 15 and 16. This is the code which you can see QIK equal to AK into pi IK into PK into WI, where AK we are going to compute as this user input, design horizontal acceleration spectrum, which you can find from the clause number 6.4.2. This Z by 2 I by R SA by G, that we are going to calculate, user need to calculate, and WI we are going to assign the lump mass weight of the structure. This is WI. So regarding this I will give more explanation while moving and understanding inside the session. So this is the example which we are going to take. The structure is 45.8 meter height and having 25 meter this width, and these are the detailed dimension where the front length is 30.29 and this width is 25, which is given here. So in this particular structure we are going to understand different concept of the response spectrum dynamic seismic analysis and will validate this. So first of all, before moving to response spectrum analysis, you already know how to create the structure and assign different dimensions and property. So once you create that, we'll move to the seismic parameter configuration and we'll look at the different code and its compliance. And once you move inside that, based on the city or the particular zone, you can configure this factor, and based on your requirement the response reduction factor which I was talking about and the importance factor which I was talking about. In case of general building this is 1, in case of a critical structure it is 1.5, and the type of soil which we are going to configure and the type of structure for resisting the earthquake vibration, that is RC frame building, which is mostly recommended, and the damping ratio which you need to give and assign to a structure, and based on that this code will be configured. And also based on the zone you can configure your parameter and corresponding parameter like the damping and type of soil you can configure, and then you can generate and you can get this data, and after that we'll look at this. So for understanding this I'll go to start and open our exercise model. So from our exercise folder we'll be opening the particular file exercise start seismic, and you can see dynamic RS analysis as per this, and you can get this file which you can open, and directly you can assign the codes as per a requirement. So here different ways are there for assigning the codes. Inside the definition you can see the response definition. You can add the floor weight reference which I will show you. But from the scratch, if you are going to configure all these factors like the floor weights and all, that already you can see is there. Once I will delete this, you will get from scratch. So if you go to the seismic definition and you will go to add, here you can see the seismic parameter. I am choosing here IS 1893 2002 2005, and once you go to generate, it generates based on this factor. So I'll choose zone as 5, and here you can see the zone factor, the special RC moment adjusting frame. So response reduction factor will be 5 here. So during calculation you can use this, or already I have shown you the response reduction factor, which you can see from the table also, that is given. So anyway, you can use that either by using the design table or from the software. In the both way you can take the advantage and you can use this. Just you can find it, I have shown just inside the presentation. So where you can find for different structures different resisting factors and parameter which you can list from this. Maybe here you will get it. Yeah, this is the response reduction factor 5 for moment resisting frame, which we have considered here. The 5 automatically software calculates. Importance factor also I told, if you go to the important building it will be 1.5. and type of soil we are taking medium, structure type RC frame, and the damping factor we are going for 5%. and when you generate it you can see here, and this update this damping to 0.05. so this will be 1/10 of 5%, that means it's negligible. So after adding this damping factor, you can see here you can directly give here 0.05 also and generate this. So here you can directly go to the zone and whatever the factors, general building, medium soil, 0.05 and generate. This will be updated, and once you add this will be added. So here you have to add the self weight for the structure, the factor 1, and then the floor width for all corresponding floor will be configured. The self weight factor, after assigning, you need to go to the floor weight for response factor from Seismic. So except the top floor, for all the floor below the top floor the height is 42.6. so we are taking the range 0 to 43 so that all the floor between will be picked, and a dead load of 12 kilonewton per meter square for the structure for all the floors we are taking for the dead load. So this will be -12, the range is 0 to 43, and you can add this. Just like that, for the top floor, the dead load contribution for calculating the response factor on seismic weight for the floor, you are going to take 43.5, which is above this, and 46 is the top range. This is 45.8, so we are taking more value so that it will pick. So 43.5 to 46. (43.5) to 46, and this will be 10, which we are going to add. And as per the IS code, which says that for contributing the live load on the floors, which is 4 kilonewton per meter square, the contributing factor 50% you have to take. So for that we are going to take 2 kilonewton per meter square. So for applying this, we can take here 0 to 43, we are going to take 2. You can take till the top floor. (0 to 46). So this will be calculated. So here you note one thing, that you should use the positive factor. Here also you should must use the positive factor, and these are the floor weight which we have computed. So in my coming session I will discuss about how to apply the different load case, the first, second and third load case, and what are the different concept on that we are going to learn. Thank you.